Welcome to this presentation about NetVec, which is a Graph AI-based intrusion detection system developed by KMD and NEC. And my name is Jacob, and this is Matthias. We're both security architects at KMD, and we'll be going through this presentation here today. We'd like to start off by just showing the agenda real quick. We aim for 20 minutes for presentation purposes, and then 10 minutes for discussion and questions from the audience in the end. And during the presentation, we'll start off by covering an introduction to KMD and NEC as companies, for those not too familiar with them. And then we'll gradually dive more into depth about the technology in the project. So we'll start off here. Just a bit overview about KMD as a company. KMD is one of Denmark's largest IT companies with about 3,200 employees and an annual revenue of 5.6 billion Danish crowns. We deliver a lot of different IT systems, about 400 different solutions that span in a wide variety of fields. And many of these services or systems are mission-critical systems. And this means that we have a natural focus on integrity, on network, on security. So this is a natural thing for us to focus on, and also in this project. Furthermore, KMD is a subsidiary of NEC Corporation, which is a global leader in technology and network infrastructure as well. KMD has offices in many of the major cities in Denmark, and have further subsidiaries as KMD Ventures, KMD Poland. We have Idlund, Banksoft, and Charlie Tango as well. And this whole organizational structure is then covered by NEC Corporation as well, which is an even larger company with approximately 110,000 employees, specializing primarily in big data analysis, network service architecture, and artificial intelligence and biometrics as well. So about the project, getting to the more concrete parts here. You already know from the title, it's about intrusion detection. And we like to start off with just talking about how this came to be and how the collaboration between NEC and KMD actually influenced the whole project. So the idea is we have a close collaboration with NEC Labs Europe, short NLE, which is a research institute based in Heidelberg, Germany, collaborating with many of the leading universities throughout the world. And specifically at NLE, we collaborate primarily with the research group for intelligent software systems, and they expertise in operating systems, in networks, in big data analysis, and therefore is like the prime research group to contact when talking about the technology for intrusion detection, which is operating on data and analytics in the network. Additionally, this research group is naturally coupled very close together with the core machine learning team, which is extremely important to get some highly functional and optimized algorithms in the end. So the project vision here is actually to combine the forces, the cutting-edge technologies coming out of the NLE Research Institute with KMD's unique market position in Denmark and access to public sector networks and public sector data from networks. So getting into what actually is in this system. It's an intrusion detection system, so that means we have some data coming from the network, and this can be many different sources. It could be from the firewall, it could be DNS logs, it could be packet traces, or it could even be something along from proxy servers or similar. And the data is fed into an analytics core, which is where the Graph AI comes into play. This core technology does a lot of things. It processes and parses data. It creates a graph, and it outputs the final result, which is a classification for benign, malicious, and suspicious traffic. So this system looks quite similar to most other intrusion detection systems, and the uniqueness of it is the core, the Graph AI core. It's a different way of handling network data that allows us to determine more complex characteristics about the threats in an organization. So to just get a feeling of why it's important to innovate the intrusion detection mechanisms already in place, some of the challenges that face modern networks in terms of defensive abilities is that the cyber threats are becoming increasingly more sophisticated and frequent as well. And this means that attackers continuously adapt new technologies in their processes, and they increase the sophistication of their attacks. Some of what they do is that we see attackers implement different techniques for evading traditional systems, and some of which could be like fragmentation, where you send off fragmented packets and hereby bypass the algorithms looking for a specific signature of a packet. But it could also be like address spoofing, where a compromised proxy is used in the attack to bounce off the source of the attack, meaning that the algorithm looking for a certain blacklisted source would be circumvented. So alongside the hastily developing digitization of the world, and we keep increasing the amount of network traffic, looking for threats and detecting intrusions in a network becomes ever more difficult, with us looking for a small needle in a large haystack of the network. So what we aim to do here in this project is to address these challenges with the netværk framework based on the Graph AI. And I'll go back to what Graph AI actually is and cover a little bit of the details there. But netværk is a scalable AI technology for conducting analysis on network traffic and classification. It is developed primarily by the core machine learning group at NLE, and it uses a focus on behavior, on relations between entities instead of a single packet view to determine these complex behavioral patterns, and hereby recognize and determine the attack based on not just its single packet signature, but on how it behaves in a network. And this really addressed many of the challenges, as the attack can change and become more sophisticated while still giving off a pattern in the network that can be detected. So a quick example could be a malware delivery chain, where a site will change domain name and hereby circumvent a blacklist feature that flagged it as previously. The context in which it exists in the network might be the same, and netværk would be able to detect this in many cases, because it's based on the behavior of the threat instead of the signature of it. So what is actually Graph AI? When we talk about graphs, we talk about a specific type of data modeling. And we talk about data modeled in terms of edges and nodes. Often you'll see it illustrated as the figure over here, where you have nodes, the entities is the circles, and then you have the edges, which are the lines connecting the circles. And that means that it's a way of mapping entities, how they relate to each other. A node in a network sense could be an IP address or a domain name, and the relation could be connected to, or rejected by, or belongs to, or there's a lot of different ways you can categorize and use those connections to map these complex networks. But nodes represent entities, and edges represent relations between them. And data is really seen in this triplet format, where it always has a place it comes from, going, and somehow of relating to it. Yeah, and combining this with machine learning technology is really where we try to determine the behavioral characteristics then. So the system itself is divided into three sections. We start off with the data parsing, which is where we gather the raw training data from the DNS or firewall or another source. And the first thing that happens is it's categorized into benign and no malicious. So we need this division, and we often take it based on a blacklist available from the firewall directly, or from an open source or another open commercialized blacklist. This is then parsed into network sessions based on time. So we know all of these domains or activities belong together, which is represented in graphs. So when we start the training, we have graphs with some of them malicious activities, some of them without, but they're all related about all these entities. It's all represented in the graph format. And this is fed to the core, the AI core of netværk, which under a number of epochs traverse the data and learn to increasingly precisely determine what is benign and what is not benign. So we have the classification algorithm. And the aim, of course, in the end, at a client, is to install this somehow in the network infrastructure, gather real-time data, feed it or convert it into this graph format as well, so it can still be accessed by the network or from netværk, and then classify it. And in the end, this classification can be used in many ways. It can be used in security reporting, a warning system, or it could be directly integrated into a firewall, where it could serve as a block list and act on it. So we have some initial results from collaboration with Kerteminde Kommune, which is a client of KMD, where we deliver network infrastructure. And we agreed to make an initial analysis on about 550 log entries from the firewall, which accounts to about 1 week of data. And bear in mind, this is still a fairly small amount of data. But what actually came from the analysis was that the firewall, or the existing security mechanisms, would flag 102 domains in this data section as malicious. But netværk would flag 133 as malicious. So this is potentially a 130% increase. And to make sure that this is not full of false positives, we verified the result with VirusTotal database, which is a collection of about 70 plus commercial blacklists, and whether or not they flag these as well. And the results are that it does hold. And this means that many of these domains that netværk flag, but the existing mechanisms don't, they somehow are skipping through the existing mechanisms. And the reason why is because they may portray, or they may exist alongside the known malicious activity, but they won't be flagged themselves. But because netværk looks at the behavior of them, and they always portray or exist alongside some other malicious activity, it's able to go in and say, okay, this one should actually be flagged as well. Some kind of considerations is that the training data is still very small, relatively, and hyperparameter optimization is yet still to be done. So hopefully the precision will increase even further, and even more domains will arrive. And the really key point and takeaway from this is also that by making additional evaluation of the results, NLE has made some larger historical evaluations of how the data works and how the analysis results compares. And what they found out is that netværk is actually able to detect and discover these malicious entities years before the commercial blacklist. So many of the domains we flag now with netværk will become flagged by traditional commercialized blacklists within a year or two. And these results are quite interesting, because what they say is actually, as seen on this graph as well, that within the first year, 12% of the suspects defined by netværk were also defined by other commercial blacklists, and up to 40% within the next 2 years. So there's a feeling that because we can target the behavior and not the signature, we can get to the threat earlier in the progress, which is extremely important. A brief summary. netværk project is this intrusion detection system based on Graph AI, and the core technology is developed by the machine learning group at NLE. KMD provides the access and the software development around the data. It utilizes the strength of Graph AI to naturally represent behavior and detect behavior patterns reflected in the network threats. And it helps address some of these challenges that modern intrusion detection face. So the results from Kerteminde Kommune showed this 130% increase in detected domains, and also that it is in many cases able to discover these malicious entities just before the traditional commercialized blacklists. So that is really the key takeaway from this presentation, is that it detects something that will be verified by other blacklists later on in the trajectory. So I think that was it for the presentation. And if anybody has some questions, you're more than welcome to ask us. Yes.
We have some quite tangible examples from the POC with the Kerteminde, in which we use netværk. We have sent logs to this netværk solution, and we were able to see that, as Jacob mentioned, that the netværk application it gathers a list of known bad URLs. And by using this list, if you are accessing some other sites at the same time at which you access these known bad sites, then there's quite a big possibility that these sites are bad as well. And if this happens multiple times, then the possibility of these other URLs being bad actually is getting bigger, and this was something that our next generation firewalls were not able to actually detect. So this is some of the value that Net2Vec could provide. We have also talked about what data could be used for. I think it was mentioned that we can do some reporting. So whatever results Net2Vec is coming with is something we can make a PDF report about. We can also export the data to whatever data types you want, if it's a CSV or text file, or it doesn't really matter. And then the modern firewall solutions, they are able to actually make dynamic policies based on a text file or CSV file or something like that. So this means that once something has been learned by the AI technology, we are able to actually use these data to start blocking traffic. And that is a very good use case in our opinion. And this might be able to add some extra security to firewalls and proxy solutions like that. Yes. And of course, we can treat different kinds of data. Firewalls, there is a different level that you are logging from a firewall or a proxy solution, and this could be something like a country if you're using geo-IP lookup. It could be something like a username if you want to track specific user behavior, or whatever the firewall is able to log, we can get. And we can also, with Net2Vec, get the logs from, for example, from Active Directory. And we can actually take the firewall logs, source IP addresses, and correlate this with information from the Active Directory audit log, and in turn know who the user would be. But there's also a possibility that we get this information from the proxy solution themselves, because they often have this kind of integration with Active Directory. So yeah,
I think that was the key takeaways from the project. Thank you.
Thank you.